Hello student, today I am going to discuss very important topic from class 1 portions, which is nothing but a basic concept of chemistry. And in basic concept of chemistry, there is a very important concept is there, which is nothing but a mole concept. So in this mole concept, we are going to discuss very important corner, as well as this chapter is not about only the chapters. It's like a tools. It will be utilized over the all other chapters. Like this mole concept can be utilized in atomic structures. Mole concept can be utilized in solid state. Mole concept can be utilized in electrochemistry. Mole concept can be utilized in chemical kinetics. So mole concept will be utilized in every chapters of chemistry. So this mole concept is very important not only for CBSE exam but also for JEE and NEET as well as for JEE Advanced. So I will cover up from CBSE level to JEE Advanced. So now let us start with the very small thing. If I write down 1 dozen of pen. So if I write down 1 dozen of pen, everybody's mind automatically it will come. There is a 12 pen is there. There are 12 pen present over here. Now, if I write down there are 1 spar of pen, 1 spar of pen, then immediately everybody's mind it will come there are 22 pens is there. So that means 1 dozen and 1 spar, what it is? It is nothing but a counting unit. So exactly likewise, the mole is nothing but a counting unit. So now 1 mole equals to 6.023 into 10 power of 23, which is called as a Avogadro number, Avogadro number, because the great scientist Avogadro was there, and in the name of that scientist it is denoted as a Avogadro number, and it is represented by Na. So now when I am speaking 1 mole, immediately it should come into your mind that 1 mole equals to 6.023 into 10 power of 23. So now what is mole? Mole is also nothing but a counting unit like a dozen, like a spar. By mole what we used to count? By mole we used to count atoms, molecules, ions and fundamental particles. What are the fundamental particles? Fundamental particles are electrons, protons and neutrons. So by mole we always used to count in chemistry in the atoms, molecules, ions and fundamental particles. Fundamental particles are electrons, protons and neutron. If I write down 1 mole of hydrogen atom, what it is represent? That means 6.023 into 10 power 23 of hydrogen atom. Yes or no? So then if I write down 1 mole of hydrogen molecule, what will come into your minds is nothing but a 6.023 into 10 power 23 hydrogen molecules. Yes or no? Then if I write down 1 mole of hydrogen ion, what it will come into your mind, my dear student? 6.023 into 10 power of 23 hydrogen ion is there. Yes or no? So now if I write down 1 mole of electron, So immediately what will come into your mind? 6.023 into 10 power of 23 electron. Yes or no, my dear student? So if I write down 1 mole of neutron, so if I write down 1 mole of neutron, if I write down 1 mole of neutron, immediately it will come into your mind 6.023 into 10 power 23 of neutron are present. That or no? So that means 1 mole of electron or 1 mole of neutron or 1 mole of anything always signifies 6.023 into 10 power of 23, that much of substance. If I say 1 mole of human beings, 1 mole of human beings equals to 6.023 into 10 power of 23 human beings are present. Yes or no? So now let us discuss with the details of mole concept. So now if I just asking you in a sample there are 6.023 into 10 power of 23 hydrogen atom is there, and I am asking how many moles of hydrogen atom is there, then how we will calculate? Let us start with that calculation. Immediately from here you will say, sir, already you written 1 mole of hydrogen atom equals to 6.023 into 10 power 23 hydrogen atom is there. So now if I is saying like that in a sample there are 6.023 into 10 power 23 hydrogen atom is there, immediately you will say, sir, 1 mole of hydrogen atom is there. How it is coming? So now let us derive one formula for calculations of a number of moles in terms of a number. Suppose I am telling you have a 6.023 into 10 power of 23 of hydrogen atom is there in a sample. Then I want to find out number of moles. Then number of moles will be equals to, it is denoted by small n, which is nothing but a number of moles. So then number of moles will be equals to the number giving into the problem divided by Avogadro number. What number given to the problem? Because we are talking about they are in a sample 6.023 into 10 power of 23 hydrogen atom is there. That is my given number. So now number of moles will be equals to given number by Avogadro number, where capital N is a given number in a problem, given number in a problem, and Na is, we know, Avogadro number, which value is nothing but a 6.023 into 10 power of 23. So then number of moles equals to, in terms of a number, given number by Avogadro numbers. Given number is whatever they are giving into the problem, that number divided by Avogadro number. If you do, then you will get the number of moles. So then we derive a one formula to find out the number of moles. What is that? The number of moles denoted by small n will be equals to given number into the problem divided by Avogadro number, directly will give you number of moles. Is it clear to everybody? Okay. So let us going to the next level. Based on that, what we understood, based on that one problem came in the year of around 2017 or 2018 in JEE. What problem came? They asked like that problem based on whatever we discussed or whatever as of now learned, based on that problem came in terms of a number of moles, in terms of a number. Because number of moles can be determined in terms of a number, in terms of a mass, in terms of a volume, different ways we can determine the number of moles. But I will explain all the things one by one. I will upload my video every chapter and in every subtopic one by one, and there we will go for a discussion in detail. Now let us look at how we can calculate the number of moles in terms of a number in JEE problems. Okay, so now let us look at that problems. So what they ask? They ask like that, in an ozone sample, I hope everybody knows the ozone formula is O3. Yes. So in an ozone 10 standard, I hope you people already came to know symbols, molecular formula, everything. Anyhow, other video is there for me. There also detailed discussion is there regarding that. So in an ozone sample, 18.069 into 10 power of 24 ozone molecule is present. Ozone molecules are present, and they asked the 3 questions. What are the questions? The questions was there. First questions they asked total number of moles of ozone, total number of moles of ozone, how much is there into the sample. Next question what they ask? Next question they ask total number of oxygen atom into that ozone sample. Total number of oxygen atom into it means in this ozone sample. Okay na? Then third one they asked total number of moles of oxygen atom in this sample, how much they ask regarding that. This was the questions for JEE. In different case, different year they ask like that. Now, as of now, just we learn how to calculate the number of moles in terms of a number. So now, first questions they ask total number of moles of ozone, and in a problem there is one number is there, and they are asking the total number of moles of ozone. Just now we derive a formula how to find out the number of moles. Whatever number they are giving into the problem, straight away divided by Avogadro number will give you the number of moles. Yes or no? So now let us do that operations. So now number of moles of ozone, first question. So number of moles of ozone, how we used to write down like this, because this small n is nothing but a number of moles, and for what? For ozone. So that's why number of moles of ozone will be equals to the given number of ozone into the problem divided by Avogadro numbers. We will do that things. So then in a problem what number they are giving, because formula is given number by Avogadro number. So then what is the given number they are giving, my dear student? 18.069 into 10 power of 24, and Avogadro number we know 6.023 into 10 power of 23. Then this is a simple calculation. I hope you know the calculation better than me. I am very much sure about it. So now 6.023 is 3 over here, and 10 power of 23 here 10. That means 30 mole is coming. I hope everybody got this one. Yes or no? So now we got the first answer directly by putting our formula. What formula we derive? That is number of moles, which is represented by small n, and then given number of ozone into the problem divided by Avogadro number. And after that calculations, you are expert on that, and we got that 30 moles. Is it clear? Now next question come into. They are asking total number of oxygen atom in it. Now O3 is a formula of a ozone. I hope everybody knows. In here O3 is there means in an one ozone molecule there are 3 oxygen atom is there. That is everybody knows. And structure of ozone of these things, there these discussions will be there in. This is the structure of ozone. These will be discussions in the chemical bonding chapter when I will teach you Lewis-Dot structure. I will explain in detail. No need to worry for that. Okay. So now in an ozone sample there are 3 oxygen atom is there. Now we are going to calculate total number of oxygen atom in it. So now we got that total how many ozone molecule was there. They are telling in an ozone sample this many ozone molecule was there. 18.069 into 10 power of 24 ozone molecule was there. And in one ozone molecule how many oxygen atom is there? So one ozone molecule there are 3 oxygen atom is there. And then total oxygen, number of oxygen atom they are asking. Then total number of oxygen atom. So total oxygen atom will be equals to 3 into total number of ozone molecules. Why? Because in one ozone molecule there are 3 oxygen atoms is there, and 18.069 into 10 power of 24, how many oxygen atom will be there? Multiplied by 3. Simple logic. 1 apple 10 rupees, 10 apple 10 into 10. So in one molecule 3 oxygen atom, and 18.069 into 10 power of 24 ozone molecule, how many oxygen atom? Multiplied by 3. Yes or no? So then we got total number of oxygen atom is this. Then the last questions what they are asking, total number of moles of oxygen atom. Now we got the total oxygen atom is this. Yes or no? We got this much of oxygen atom. Now my given number is this one when we are going to calculate the number of moles of oxygen atom. So then for that third questions, number of moles of oxygen atom. I hope everybody knows this representation. This is represent number of moles. This represent number of moles, and this represent your oxygen atom number of moles. So same given number divided by Avogadro number. Given number for what? How much total oxygen atom is there. Now the given number is not 18.069 into 24. That is ozone molecule. Now total oxygen atom how much? 3 into this. That is my now given number. So then immediately given number is 3 into 18.069 into 10 power of 24 divided by Avogadro number 6.023 into 10 power of 23. Yes or no? So then immediately if you go for calculations, so this is roughly 3, this is roughly 10, so then we are getting 90 moles. So if you look at that all 3 calculations, how we did, again I am briefing. First we calculate the number of moles of ozone, that how we did, the number of moles of ozone equals to given number of ozone molecule divided by Avogadro number. Then regarding the total number of oxygen atom calculation, how we did, we know in an ozone molecule there are 3 oxygen atom is there, and I have a 18.069 into 10 power of 24 ozone molecule. Then total oxygen atom simply multiplied by 3. We got total oxygen atom. Once we got the total oxygen atom, then total number of moles of oxygen atom calculations we did again same way, given number divided by Avogadro number. But here given number is not the ozone molecule number. Given number means in this case the total oxygen atom. Total oxygen atom how much? 3 into 18.069 into 10 power of 24 divided by Avogadro number, which is 6.023 into 10 power of 23, and then we got the 90 moles. I hope this problem is clear to everyone. Based on that, in the year of 2019, most probably, JEE asked another fantastic problem. Let us discuss that problem, which will consolidate your learning. So look at that problems. In that problem, what they ask? They ask how many moles of electron have a mass of 1 kg. So they ask how many moles of electron, how many moles of electron have mass 1 kg. Fantastic problem. So as of now, whatever we learn based on that this problem. So now how we will do? Just 1 minute, think about that one. You look at, we can do very easily this problem. In algebra, what we don't know, what we used to do? We used to do let x, let y, let a, let z. Like that we used to take all those things. Here also I will do that one. Let x mole of electron have mass 1 kg. Okay na? So So like algebra, just I took that let x mole of x, let x mole of electron have a mass of 1 kg. You can take is your choice. My choice, I am like x very much, that's why I took it x. You can take y, you can take a, you can take z. From a to z there are 26 letter is there. Whatever you love, you can take that letter. Okay na? So I took let x mole of electron have a mass of 1 kg. So now 1 mole of electron equals to how many? I told 1 mole of anything in this world is nothing but a 6.023 into 10 power of 23. So then x mole of electron equals to x mole of electron equals to x into Avogadro number. Yes or no? Na is a Avogadro number. Because 1 mole of electron equals to Avogadro number of electron. X mole of electron equals to x into Avogadro number of electrons. This many number of electron. This many number of electron. Like 1 apple 10 rupees. 10 apple 10 into 10. So 1 mole of electron is Avogadro number of electron. X mole of electron is x into Avogadro number. Simple logic. Yes or no? So then x mole of electron equals to x into Avogadro number, that many number of electrons. Then 1 electron mass in second chapter is their atomic structure. Their detailed discussion is there regarding each of the fundamental particles. I hope you know in NCERT book it is clearly there that what is the mass of 1 electron, what is the mass of 1 proton, what is the mass of 1 neutron, and who is contributing the mass of the atom, and E by M ratio, that means charge by mass ratio. Detailed discussions will be there. You need not to worry. I am there to explain everything with full clarity. So now x mole of electron will be equals to x into Avogadro number of electron. So then 1 mole of electron, one electron mass will be equals to 9.1 into 10 power of minus 31 kg. This is the mass of 1 electron. And in my x mole of electron, total electron how many is there? X into Avogadro number. This many electron is there. Yes or no? So now mass of 1 electron is 9.1 into 10 power of 31 kg. Then already in the problem I told x mole of electron mass is 1 kg, I assume first. Then x mole of electron means how many? This many number. 1 electron mass is how much? This. Then if I multiplied x into Na into, that means this many electron, each electron mass is how much? 9.1 into 10 power of minus 31. So then if I multiplied this much 9.1 into 10 power of minus 31, and then this should be equals to 1 kg. Why? Because initially in the problem I told let x mole of electron mass is 1 kg. And then that x mole I converted to a number by multiplying with Avogadro number. And then multiplied with the mass of each electron, then I got x mole of electron mass, and that is already I told it is equals to 1 kg. Then I equate is equals to 1 kg. Then this is a one equation, one unknown, which is x is unknown. From this equation I can get the value of x. X equals to 1 by Avogadro number into 9.1 into 10 power of minus 31 kg. This one will, this means this will come in mole, because this is their unit is there in this unit will be their mole, and this is there in kg. So then they are asking how many moles of electron is there, then we will get the how many x value. So then you put the value of Avogadro number 6.023 into 10 power of 23 and into 9.1 into 10 power of minus 31, and this is the simple calculations. You can do these things easily. If you roughly want to do, then roughly I can do very easily. You can take instead of 6 point exact answer in exam also there is a trick is there. How can easily can do these things? You look at this is a decimal point multiplication. So then if I take instead of 6.02, if I take only this is 6 and this is 9, because 9.1 means almost close to the 9. Na? So then 6 into 9, 54. Then I will do 1 by 54, and here 10 power of 23 and 10 power of minus 31. So 10 power of minus 8 will be there, and if you take in numerator, it will be 10 power of plus 8. And then 1 by 54 you will calculate, and then you will do that 1 by 54, you simplify in decimal point, and already 10 power of 8 will be there over there, and you will do the calculations. Yes or no? These are simple calculations. I hope everybody understood this one. And next video also, I am finishing this video over here. Next video we will continue with this mole concept with the number. After that atomic mass concept will come. After that molar mass concept will come. Everything relative atomic mass, average atomic mass, everything one by one will come, and mole calculation in terms of mass, in terms of a volume, one by one it will come. You just look into the video one by one and keep liking and subscribing. Thank you.